Thank you. Today we are talking about power supplies, solutions for power supplies, and your host details. We are here. So Massimo Pagani is our colleague responsible for technical support at GMI. We are based in Italy, and Massimo is based also in Italy. He has a very long experience in electronic device and also all related questions related to process industries. Has more than 20-year experience and is also responsible for completely for our, as I said, our assistance with the customers, and also supports an R&D department for new products. It's also a functional safety engineer. Myself, Andreas Poror, I'm responsible for main account. I'm experienced is based in Italy on the main automation areas for machinery, and then I moved to process industries. I'm also responsible, also functional safety engineer. Let's go quickly. I would like to introduce a little bit of GM International for the people doesn't know our company. We are a company that produces intrinsically safe and seal-rated devices for main critical applications, oil and gas, chemical, petrochemical, mining, food. More than 40 experience in electronic production. Former company was Econ Instruments. We produce completely in Italy, but we have a global presence in 5 continents through our subsidiary. This is the part of our products. We produce intrinsically safe barriers or isolators, safety relays, isolators for safety applications, sorry, for non-safety, not PX application, but for accelerated isolators. Power supplies, that is the topic of today. Multiplexer for temperature and digital signals, termination boards, hard multiplexer, charge protection indicators. And the last bullet is regards our courses and the trainings. So we are proud to tell all these kind of trainings for mainly for functional safety engineers and also ATX applications, EX applications. This is one slide regarding our certification. We have a product that is certified from different accreditation bodies, 15 exactly. And so we have all certification for different markets, different areas, and different also field applications. We have also EX, of course. We have also maritime applications and specific application for industries in areas like China or Brazil or Japan and so on. Another slide regarding our production. As we said, we completely produce in Italy, but we have complete traceability for incoming outgoing products, and all products that we supply have been tested 100%. This is our organization in the world with different offices, 10 specifically. We have also different distributors, or technical distributors. 200 people, the number of persons that follow GMI product and assist in the world, functional safety courses and different installations. Some names about our customers, so we have been certified from different end users, EPC system vendors, and OEMs. Now we can go to the topic of today, but first of all, we wanna ask you something. So if you like, to answer to this poll, it's a very simple poll. Later will come others more complicated. So it's with this, maybe try to be more interactive with you. So I see that most of you use standard power supplies, and a lot of you also use both. Also in the market, as we see, there are all applications, and maybe not all applications that we are doing dedicated for the only for safety applications. Okay, I see that most of you use both accelerated power supplies and non-accelerated. Okay, we can stop now and we can go to the topic. I leave Massimo.
Thank you, Andrea, for your introduction, and welcome again to our attendee. Well, now let's move on to the presentation of today's topic, which takes into consideration the power supply system and the value that they have within a safety loop. Let's start by introducing the concept of a safety instrumented system. SIF is a set of subsystems that make up the safety loop. Within this safety loop, we have field devices such as transmitters or sensors, which allow us to control, detect, and measure variables in the field, such as temperature, pressure, or other. They are driven by barriers or isolators that provides for limiting the current towards the hazardous area or to isolate field instruments. And in turn, the signals sent by the field loop will be acquired, managed, and interpreted by what is the brain of the SIS or the PLC-DCS system, which will decide on any action to be taken to make a plan to save. And again, power interfaces as can be a safety relay, which will connect on a valve and on an actuator, which allow us to bring the system safety in case of need. The main concept that needs to be understood is that every single element of the system must be sized with a seal level, such as to allow us to obtain the overall seal of the system required. All the power supplies that will be part of the SIS, for example, those that will power the PLC-DCS, those that will supply voltage to operate valves and actuator, those that will allow barriers, isolator and transmitters to work properly, will also apply fundamental rule in a safety related loop. And it's also important that they also have an adequate seal level. All components of a SIS, including power supplies, must be safety related and have a seal level. This helps us to have a safety loop and with the correct redundancy, a loop with high availability to the process. Now, let's take a look at the power supply. What are the possible risks and conditions that we consider dangerous in relation to the use of a power supply? The concept of a safety is very important, also with regard to power supply system, because the failure of a power supply can cause serious accidents that lead to serious losses in terms of human lives, serious environmental damages, and serious cost losses for companies. For this reason, it's necessary to have safe devices that guarantee high performance. But what are the dangerous conditions for a power supply system? Well, mainly there are two dangerous fault conditions. The first one is an indefinite load voltage in a range between 2 and 20 volts. Must be considered as dangerous failure of a power supply. This is because an incorrectly powered load works or can work out of specification, and this leads to a reduction in a load performance that can cause a premature instrument failure. Often we try to avoid this issue using redundancy, but we mistakenly think that two power supplies in parallel are sufficient to make us immune from possible faults in the power supply system. Redundancy cannot solve on its own and cannot guarantee us immunity from power supply failure. because a standard power supply system, it does not take into account the common mode faults that can afflict standard power supplies. These common mode faults can cause spurious system faults with their related production downtime, which will significantly affect cost. The redundancy of safety power supply minimizes this risk because common mode failure are considered in the SIF calculation necessary to get the certification for a safety-related device. The second dangerous failure condition of a power supply is when the output voltage reaches a value higher than 30 volts. In this condition, the load is subjected to an extra voltage which can damage it, or in case of output voltage higher than 50 volt, the field instrument can suffer a definite disruption. We can take, for example, an NG schooling system which works thanks to a standard power supply. Suppose that the standard power supply fails and goes into an overvoltage condition, damaging the cooling system. This will lead to an overheating of the engine, which will lead to serious consequences for the whole system connected to it. Once again, I want to underline the value of having a safety power supply system which guarantees us high performance and high safety. So, why it's correct to use a safety power supply system? Below are the main reasons that lead us to advise against to the use of a simple standard power supply. A standard power supply is not designed based on the directive of ESC 61508. It does not have made a calculation defined for the safety function to obtain. It does not allow to have redundant protection for overvoltage issue, while in a safety power supply system, redundant protection are a fundamental requirement. And again, standard power supply can be used in a redundant configuration, but they do not guarantee that our application is totally safe, for the reason related to the common fault which we have seen previously. And also, standard power supply often require external ring diodes to allow for redundancy. This means to add external wiring that, especially for high load currents, create a high voltage drop which has a strong impact on the supply voltage. It's true that it's possible to adjust the output voltage to compensate for the voltage drop, but this operation increases consumption considerably. In addition, standard power supply has a high number of spurious faults that a safety power supply. We know well as a spurious fault can also lead to dangerous failures for the application. And again, standard power supply use internal components with limited operating range to keep cost down. This affects the lifetime of the device. For this reason, internally to the safety power supply are used components with a higher operating range that allow the system to work at a lower stress level. This leads to less failures and consequently a considerably longer life than standard power supply system. At this point, why it's important to use a safety power supply system? First of all, we know that the standard voltage for a normally energized load is in the 20-30 volt DC range. As we have seen previously, conditions that lead to power supply output voltages between 2 and 20 volt and higher than 30 volt are considered dangerous failure, which negatively affect the application. Well, a safety power supply significantly reduces undetected dangerous fault thanks to a built-in diagnostic system. In fact, if an anomalous output condition is detected by the safety power supply diagnostics, it brings the output to 0 volt, which represents the safe fault condition. Plus, a full transistor alerts the PLC system, which can act as per C specification. Even in case of a safety power supply output over voltage condition, the internal diagnostic activates the redundant protection system for limiting the output voltage, which bring the latter to a 0 volt. This means into a safe fault condition. Now, we introduce the concept of a safety power supply applied to a typical application as a DTS, the energized to save, or ATS, energized to save. As we know, typically the safety systems are designed to remove power to the system. DTS, the energized to save application. And therefore, the failure of the power supply, which goes to 0 output volt, is considered a safe failure. So we can assume that all safety functions are DTS or the energized to triplet type. Really, there are many applications where the safety function is to energize the load. Therefore, of the energized to save or energized to trip type, as in fire and gas system. A safety power supply is designed to guarantee a SIF2 or SIF3 safety level also for energized to save application, which need to energize the load on request. Well, for this type of application, redundancy and overvoltage protection are essential. A power supply redundancy system must be used when the safety of the power supply is essential. For this reason, the redundant power supply systems are used in critical sectors such as the oil and gas or pharmaceuticals, and in all those applications where the loss of power supply translates into the loss of sensitive information, or in all those applications where the certainty of having a correct power supply on request is fundamental. It must also be used in all systems where every minute of production downtime is extremely costly. Let's talk about system available to the process. Next slide, Andrea, thank you. As we see from the slide on the screen, for the energized to save application, typically normally energized loads, the SIF3 safety level is easily reached through a type 1 of 1 or type 1 out of 1 configuration. For this type of application, we can achieve true redundancy and increase in availability to the process. This allows a further quality stepping guaranteeing production continuity and the plant and higher safety levels. As regards energized to safe application, typically normally the energized load, as mentioned above, redundancy is essential to reach a SIF2 or SIF3 level. In fact, without redundancy, a single safety power supply is only SIF1 level, can be reached, and also availability to the process is low. But by composing a configuration 1 out of 2 or 1 out of 3, it's possible to get a higher SIF level up to SIF3. And at the same time, increase the availability of the process also for energized to save application. Overvoltage protection. Overvoltage protection, as mentioned above, is fundamental in a safety power supply system. because it allows us to reduce the risk of the system downtime considerably. In fact, if one of the safety power supplies fails in an overvoltage condition, the protection brings the output to 0 volts, allowing the other safety power supply to continue working correctly without the risk of sending the system to shutdown. A standard power supply without protection would cause a shutdown of the whole plant with the consequent repercussion of productivity and costs. A SIF-free level power supply system with overvoltage protection is able to increase operational safety, productivity, and reduce its cost. In the following slide, we see what is the way that the individual subsystem have within a SIF. It's important that every single component of a SIF, including the power supply system, is included in the PFD average calculation to achieve the required safety level. Every single element has its own percentage weight, which must be considered. Below, we see other advantage that using a safety power supply brings. First of all, it can be installed in Zone 2, Division 2. This allows us to reduce wiring cost as it can be installed much closer to the load. More power in a small space with the use of rack system up to 6 power supply inside. The rack system also allows us to reduce wiring cost and allow us to have the diagnostic module on board to control all the main function of the safety power supply system. It's also possible to connect via Modbus the diagnostic system to a remote system. And we have easy maintenance and troubleshooting thanks to the hot swapping system, which allow the live replacement of an element in the rack without having to disconnect any connection. And again, operation in harsh environmental conditions thanks to the vibration test and extended temperature ranges up to 70 degrees Celsius. And as mentioned so far, availability for safety related application up to SIF-free level. Here we show the typical application where safety power supply are used. For example, offshore platform instrumentation or system firing gas packages, BM and BCS system, and the supply or SD system, etc. Well, Andrea, I finish my presentation.
We have another poll.
Yes, we have another poll.
I think you can answer to this poll as well. The presentation is finished, but we do have another presentation most related to the question that you make us during your registration time, and also questions that we got previously from other attendees. So there is, let's say, other information you can get, of course, that. Thank you for answering. I see a lot of attendees very active now. We almost reached all people. Okay, I can stop, and I want to share with you also the results. I see that the most important features and other features. Okay.
In the next short presentation, we have the question we are usually asked about today's topic. And well, Andrea, the first question is
wait. I have to
24-volt power supplies considered fail-safe PDF to 0 and do not impact the safety of the SIS.
Okay, I think you can see.
Okay,
So you can repeat a bit better now because now
the first question, the first typical question is 24-volt power supplies consider a fail-safe and do not impact the safety of the SIS.
okay. So we are talking about the power supply and the fail-safe for people that aren't familiar with this terminology, because fail-safe is a characteristic of a particular device which cause that the device to move to a safe state when it lose power. Okay. But power supplies, as Massimo explained in the previous slides, can fail in different ways. So we can say that 20 to 30 voltage is a typical range where the power supply is working. And the dangerous, as we remember, are when the voltage are higher than 30 volts, because this power can damage the instrumentation of the system you are powering. So it's very important in this case to introduce redundant protections, overvoltage protection, to protect this out. So we have to stop and say limit the voltage to 30 as maximum value. Otherwise, you can get problems. And overvoltage, of course, are suitable for that. Also, the condition between 2 and 20, so the lower values, are also conditioned because this can have, let's say, instrumentation you are powering with that value can work out of typical operating range, so can cause some factors. So, and this condition is avoided with the redundancy of the power supply. So if you have two power supplies, of course, and one is supplying less than 20 volts, the other is will compensate and will force the system working right. But when you are using also two power supplies, very important, consider there is a beta factor. That the beta factor is the condition that is influencing the system. So the beta factor means that the two power, two systems, two devices working in a redundant system can fail at the same time with high probability. So the beta factor is very, very important when you use two redundant devices. Okay.
Okay, the next one is how power supplies can influence performance of SIS and what is their design and preventive maintenance requirements.
Okay. So in the system, safety instrumentation system, is designed, of course, to trip and go to safe state by losing power. The energized to trip functionality is always called. That means that the power supplies has to reach a safe state when there is a problem. But you're aware that the system, the factory, the power cannot be turned off because there are architectural availability that has to be respected. So we say that the power has a dual role in safety. So you have the power that needs to be reliable. So meaning that the overvoltage has to protect from high voltage or under voltage also has to be avoided. And the both, as we said, could cause an instrument to fail and not go to safe. And also the power needs to be available. So that's the reason why redundancy and load sharing are fundamental features for your power supply. So load sharing means that you are sharing the power between two units, minimum. And in case of problem, the one is taking over the power in order to not stop the system. So Prevent maintenance and testing proof. That is also important because I think for the ones that already participated or did some activity, functional safety, this is the graphic to show that how the probability failure demand increases by the time. And so when you start operating today with a device, with a power supply, which is maybe certificate for CO3, by the time this certificate is no longer valid, and you will go out from this CO3 band, you go to CO2 and the CO1 again. So the preventive maintenance and testing proof activity is, and the testing is very, very important to keep a certain level of safety in your application. I see that there is one question probably from one attendee. Massimo?
Yes, Andrea, we have a question from our attendee. Does power supply take part in SIF calculation in a SIF loop? Yes, I think that it's mandatory to have safety loop. Is mandatory to have a SIL power supply certified.
Yeah, you have shown previously that is take a big weight on your SIL total percentage. So it's a few percent. If I remember, was around 6-7%. So it means that that is definitely important when you are calculating your SIL loop level.
Okay, well, Andrea,
yeah.
Next question. Some words about safe and dangerous failure, possible differences.
Of course. This is also very, very important because we can differentiate a normal state, non-energized application, a normal state of non-energized, or safe state, normal de-energized. So, in the means that for 24-volt power supply, the voltage is within the range between 20 and 30. So we have already said that the dangerous state is when the output voltage is lower than 20 or greater than 30. In both cases, we can have problems. So voltage lower than 20, you can the instrumentation could work out the specifications, while the 30 plus voltage, or probably 50, may destroy all the instrumentation supply. We have an experience with that, with other power supplies, people that say that they had big problems because the switching power supply, which is rated 400 voltage side, for problems that the voltage went directly to the system, and that destroyed completely that system. So the certification grants that probability failure on demand, PFD, is suitable for the SIL level specified. So if you have SIL2 or SIL3, for instance. So, and in this case, the multiple voltage protections can grant a very low failure rate. And the possibility can increase the SIL level or the availability also, but we are talking about SIL because safety is SIL. Availability is not taking count. Okay, it's not taking count in that calculation. So the SIL is increased by 1 or 2 redundancy. So the typical SIL level for non-energized or single power is SIL3, also without a redundancy, as Massimo showed in the previous slides. But if you have a normal de-energized application, the standard is a SIL1. If you wanted to reach SIL2, you need at least 1 redundant power. And for SIL3, you need a second redundant, so 3 modules in order to get to reach a SIL3. So we have seen that the redundancy is also important. Redundancy is also important for increase the availability. Okay, we can go through that.
Next one, often we are asked to ask what is the difference between safety and availability.
Yes, very, very important. Yes, we have already discussed about that. Said the safety is the only parameters that functional safety of the seal is looking. So it's based on the ISC 61308 and ISC 61311. First is for manufacturers, second is for users. It's the safety standard for process industries. And so a device to be safe is able to, to do something. So basically application are open or closed valve, start, stop, and motor. That is the function required. Okay. So why availability is the proportion, definition, proportion of time for which the equipment is able to perform its function. So availability is different from reliability. So I would say that reliability is more related to the probability and demand, probability to the safety, to the seal level. But availability is very, very important because it's the really, it's you don't have available function, means you are not able to produce working because of failures. It's not maybe doesn't pose any really risk or problems for people and for the plant, but stop your system, stop your production, which is also very, very critical. We want to show you again this graphic. It was also in the previous slides, but we want to repeat that because it's very important. So repeat that for non-energized applications, okay, if you use one seal-rated power supply, seal-free, one is enough to reach, to maintain, to keep a seal-free. Okay. If you add another power supply in the redundant configuration, the seal remain always still at the third level, but you increase the availability. Okay. While for normal de-energized application, if you use just one power supply, it's only valid only for seal 1. If you want to reach a seal 2, you need the second one. A seal 3, the third one. That are the standards.
Well, what are the possible configuration to reach the highest seal level?
Yes, we have another example here. The table, the blue here, is valid for normal energized load. So let's look at normal energized load, which are the most common application. So for instance, let's look at our power supply, single power supply, the first line. And it's in this case, we see that that is 35% rate, okay? And it's only taking 10% of the total SIF. I can have a T-proof, so I have to repeat the testing to keep the SIF-free level every 1.5 years. Okay. If that same power supply, so the second square here, if it's working 20% of SIF, the testing proof is valid for 3 years. So you can keep on the working that power supply for 3 years. While if you use the same power supply, because you know, if you use a seal-free system device, direct device, you can use it for seal-free, of course, but you can use also the seal-2 application. Okay, no issue for that. So if you use the same power supply for the same 10% of the seal in the seal-2 application, that T-proof time will be valid for 18 years. If you use for 20%, will be valid for 20 years. 20 years is the, let's say, the lifetime of the device. So that is stopped at 20 years. If I use the same power supplies in the two parallels, so in the redundant, I see that I increase a lot my test improve time. So I reduce my testing or my maintenance on my system to 8 and 16 years. And also that is value procedure. For 4 or 6 parallel power supplies, I have different values. Besides, there is also the values for normal de-energized load, which are a little bit different. Okay.
Okay, well, and again, we have another question. Typically, as a state power supply shall be used for the system that only participate in a SIF.
Okay, yes, yes. Of course, we have repeated a lot of times. So for all the system involved in the SIF, functional safe power supply must be used because it is functional safety parameters. So the parameters of the power supply have to be considered together with the other devices belonging to the SIF. So that is fundamental. So power supply is very, very important. If I don't, we are not using, we are not applying the power supplies for safety application, not for standard power supply can be used. In this case, the only difference from non-safety applications is that the safe power supply is much more reliable than, or not much more reliable, but we say that the reliability is proven. Why on the standard power supply is not proven? As Massimo said before, components inside of the safe power supplies are specific components with a specific range, specific values, and so on. For standard power supply, that is not say proven, at least proven. Maybe are good, but the values are not proven.
Well, Andrea, now we can spend some words about a very important feature for uh, safety power supply system. Is there any solution for installation in hazardous area?
Yes, I don't see further question live. Don't worry, gents. If you want to make question, please do it. We are ready. This is the certification for zone 2 or div 2. Our solutions are also available for that market. So we are talking about ETX application, EX applications, and ICX. And also we are offering, so the GMI solution also consent also the hot swapping in zone 2. So the single modules can be removed from the rack. So in this rack, on the blue one, right? You can remove the units, okay? And in case you're using a redundant configuration, so you're using two power supply redundant system, the other module or the other modules, maybe you can have more than one in the redundant, will take over the power supply for the system without and down system. So you can keep the system working while you are maintaining or replacing the power supply unit. There are some switches inside that say grant or allow the hot swapping.
Yes, this system is a mechanical system that allows us to discharge the internal electrolytic capacitors to avoid the spark in dangerous area that can cause the explosion.
Yes, and we have also, if you're using a rack like this one, and also the most important thing that you have not to dewire the system because just screwing the screw here, you can take out one unit and all the rack is always wired and is working correctly. So you don't have any the wiring operation. That is also very interesting when we are operating. Okay, let's go to the further question.
Yes, is for diagnostic for power supplies with Modbus interface.
We realized, we also in the previous slide, there is this module which is optional, and it is say, diagnostic display, not only display, but first is a display because it can show all parameters regarding all the units connected. You can see the voltage out, the current out, you can see the temperature, the frequency, all parameters are available. Also the current sharing percentage and temperature to be saved. And also any fault can be reported, can be displayed, can be also reported to the system because there are two ways you can have a common alarm to a content you can transmit, and also there is the Modbus RTO, so the bus, the field bus output. Through the field bus output, you can discriminate exactly what fault happens on your power supply. That is the really value. And all systems basically support Modbus RTO communication.
And I wanted to remember that the diagnostic is very important to reach higher sea level, especially in application as fire and gas or energized to safe application.
Yeah, because you also, if you have a monitoring system, you can, the undetected the undetected dangerous failures can be say reported, transformed into detected failure because the diagnostic will transfer this information to your system, and in this case you can know what's happening. If you know that failure will be detected, if you don't know, it will be undetected. That is very bad for your safety application.
Well, and now a little comparison between redundant power supply, rack, or class wiring.
I think Massimo can answer to this question probably better than me, of course.
Yes. The rack system of power supply is very important because allow us to already paralleled and the power supply system. This allow us to have redundancy available on the rack, and maintenance don't require wiring disconnection because we have the possibility to use the hot swapping system, and connection or disconnection during normal operation also in zone 2 division 2, and very important feature, the diagnostic module available on the rack system. In the standard supply system redundant, we need to connect externally, and for maintenance require the wiring, the power supply, and again in a standard redundant system we need to use an external diode for redundancy. Instead, in the rack system, the O-ring diodes is already inside to the system.
Okay, thank you, Massimo. So I think
well, and again, what's happened if one device connecting to the power supply shorts?
yes, that is happens a lot of times, especially if you have if your power supply is connected to different loads, and all power supply basically stop working in case of shorts. When they detect those shorts, they stop working. It means that all loads will be stopped. So, but we developed a special features on our power supplies. And in case of short circuit, GMI power supplies really deliver and generate a high peak of current in other amps. We are talking about very high current for a small duration, zero point 0.5 milliseconds, in order to say open completely and blow the fuse of the circuit breaker open to avoid the power supply shutdown. So the other people connected to the power supply will continue working without any problem. So this is a special feature that developed in cooperation with the customer that required that features. Basically, we have finished. I see that all people are, most of all are still connected. So thank you for waiting. We have just a few things we want to remind you. So our webinars, you can look at our webpage, GMI webpage on LinkedIn or whatever you like. You can see all the scheduling for the next days, the next weeks. If you want to register yourself or send to other people, don't worry, you can do it. You can also look at this webinar because it's been stored, it will be stored, not yet, in our YouTube channel. And you can see all the others also that have been recorded. And we have the last poll. Thank you. We wanna. If you wanna answer, thank you very much. We take just the last minute of your time, and then we can say thank you to you, and have a good time for all of you, especially in this bad period, I think, and strange period due to the COVID. Okay, thank you very much for voting. I don't want to share that those things, but you wanted to thank you very much and remind you also our contact. If you want to send us an email, if we didn't answer to your question, you can write us or phone us, whatever you like. And thank you again, and keep safe.
Thank you very much.
Thank you, Massimo.
Thank you, Andrea.